Okay, go ahead and start with the exploration. Okay, so you're doing the first two A's and B's. So AB and then you're done. Okay, so if you're following the patterns for 8, 9, and 10, all that's happening is the little like shaded ball thing is just moving around the corners of the triangle, right? So it comes here, then it goes up there, then it comes back here, right? What's the pattern happening on B?
It's swinging clockwise.
It is swinging clockwise. What else is happening? Yep.
Goes like curve straight.
Yep, curve straight, curve straight. Okay, so I'm not even going to try to draw those, okay? So anytime we look at and make inferences based on a pattern, that is called inductive reasoning, okay? So inductive reasoning, you can come down here and say based on patterns. Okay? So if you ever try to base your logic around patterns, that is called inductive reasoning. Okay? Let's look at the second set of A and B based on the Venn diagram. So it says if an item has property B, then it has property A. Does everything from property B also have property A? Yes, because that bubble sits inside, right? So that would be true. If an item has property A, then it also has property B. Does everything in A also have B? No, because this stuff out here doesn't have property B, right? None of this stuff out here has property B. So this one would be false. Okay? That is basing an argument or basing your reasoning on facts. That is deductive reasoning. Okay? So deductive reasoning is based on facts. Okay, so inductive reasoning is based on patterns. Deductive reasoning is based on facts. Seriously? I pushed the wrong button. I loaded it all onto the same page. Yes, sir.
Wouldn't the pattern also be a fact?
So let's think about that. If a pattern, in fact, did turn out to be a fact, then that would be deductive reasoning. Generally, when we say patterns, it's more just like, yeah, it's more like a trend. So, like that would be like me saying, every day Billy walks home from school, so on Friday Billy will walk home from school. That would be inductive reasoning. It's not a fact, right? Billy could be sick. Billy could have some kind of special activity. Just because Billy almost always walks home doesn't mean that's going to be a fact. Right? So that's more what we're looking at when we're talking about deductive reasoning. Okay? All right, so I want you guys to work together in your table groups and decide if numbers 1 through 4 at the bottom of that page are inductive reasoning and based on patterns or deductive reasoning and based on facts. Go ahead. Okay, so all mammals have hair. Cats are mammals, so all cats have hair. Is it inductive or deductive reasoning? It's deductive reasoning because those are facts, right? It is a fact that all mammals have hair. And it is a fact that cats are mammals.
I thought they were felines.
Felines are, I don't know.
Not all mammals have hair.
Yes, all mammals do have hair.
Some cats don't have hair.
Which ones? Sphinx cats do have hair. So they do, but it's very short.
They do?
Porpoises have hair. Like dolphins? Dolphins have very fine hair.
A shark, like a little.
A shark is not a mammal. No,
Pretty sure it is. It gives birth. They lay eggs.
no, it's a fish.
Sharks give birth.
Sharks give live births, but they're not mammals. There are multiple, I don't know. All mammals have hair. Be quiet. Just kidding. Okay. All right, here we go. Number 2, each time you go to school, you walk. You went to school today, so you walked. That's inductive reasoning. That's based on a pattern, right? Okay, number 3, this weekend the sun was shining and it did not rain, so the next time the sun is shining, you know it will not rain. Inductive, again, based on patterns. Okay, number 4, the product of two even integers is always even. Because 92 and 14 are even numbers, the product is even. It's deductive, right? Because that's based on facts. Okay. All right, let's go to the back page. Oh, this is totally, I don't know if this is going to mess up my recording or not. I accidentally loaded them on the same page or something like that. Okay, we'll see if that works on the, hopefully that works on the recording. Okay, so 2.2 was more getting at the last like introductory piece of proofs. A big part of proofs is being able to back up your logic, okay? So there are definite patterns that we are going to follow, but we have to be able to use facts to back up our reasoning, okay? And using those facts means that you're going to have to understand and be able to apply your postulates and theorems and different things like that. So right now we actually have a couple postulates that we already know. Do you guys remember what they are? Oops. The segment addition postulate. Remember we did that during the first unit? Segment addition postulate just meant the parts should add up to the whole, right? So the parts should add up to the whole. And then we had one that was really, really similar to that, the angle addition postulate, right? Where the two different sections of an angle should add up to the whole angle, right? So we're going to look at a couple more postulates today. They're really simple ones, and we're just going to kind of keep getting our feet wet a little bit more and more and more until we are able to full out do a proof. Okay, and that'll be next class. I don't know. We'll see. Okay, correct. You will be doing e-learning, so we'll see how that works. Okay, so let's look at these two postulates here. 2-point postulate is super simple. All it says is any 2 points form a line. Okay, any 2 points form a line. So then if we swing over to the 3 points postulate, then any 3 points form a plane. It is important, I guess I should add this in there. It is important here that the points have to be non-collinear. Right, because if the 3 points lie on the same line, then they don't necessarily form a plane, they just form a line. But any 3 points do form, any 3 non-collinear points do form a plane. Okay? Alright, then we have some intersection stuff. So a line intersection postulate. What is the only way that two lines can intersect? Where would they intersect at? One single point, right? So two lines intersect at a single point. Okay, so two lines intersect at a single point. Let's go ahead to the plane intersection postulate. What's the only way that two planes intersect? They're always going to intersect at what? What kind of object are we going to be creating anytime two planes intersect, though? A line, right? So they're always going to intersect at a line. So two planes intersect at a line. Ooh, that got really sloppy there at the end. Okay, so we have two lines intersect at a point, two planes intersect at a line. Then the plane line postulate is kind of the oddball here. If a line is in the plane, all the points on the line have to be in the plane as well. Okay, so if a line is in a plane, all points on the line are in the plane. Okay. So a line either intersects a plane and only touches it at one point, or if it lies in the plane, then all the points on that line are also in the plane. Okay? Okay. That was just captured on recording. Sorry, we had a student fall out of his chair. Okay. All right, let's focus here. So we are working on 9 through 14 together with our groups, okay? Make sure. Okay, remember as you're working through 9 through 14, make sure to remember the postulates that we just went over when you're trying to determine if these things are true or not. So where it says, can you assume the statement, that is essentially asking you, is it true or false? Based on the diagram, okay? Remember not to trust your eyes, but trust the facts that you know through the postulates that we have, and the different markers and stuff on the diagram, okay? Rock and roll. All right, let's look at 9, okay? Planes A and B, do those planes intersect at line EF? They do, that's true. Okay, points C and D are collinear. What do you think, true or false? Getting a mixture. It is true. It is true. Why is it true, somebody? Yeah, Annabelle. Because it's any 2 points, right? So the 2-point postulate says any 2 points form a line. So just because there's not a line drawn through them does not mean they are not collinear. Okay? All right, 11. HJ, or ray HJ, and line ID are perpendicular. That is true. How do we know that they are perpendicular? They do. They intersect at a 90-degree angle. We know it's 90 degrees by that little 90-degree marker. So that's true. Number 12, line GD is a bisector of line EF at point D. You say true? Why do you say true? Okay, it does have the congruency markers, but pay attention. If you pay attention a little closer, the congruency markers right here are for segment EF. If it said it was a bisector of segment EF, yes, that would be true. But it doesn't say it's a bisector of segment EF. It says it's a bisector of line EF, right? So there's no way for us to really know that without the congruency markers out there. So we would have to say false to that. Does line IH equal line HG? Again, we don't know, right? There would have to be congruency markers on there for us to know if they were congruent or not. Okay, number 4, HJD. So let me highlight here. So HJD and HDJ are complementary. You think it's true? Why do you think it's true, Emma?
Because it's a triangle.
Okay.
And the angle H has a 90-degree angle.
Good. So this is a triangle, meaning all the angles have to add up to 180. This one we know is 90 because of the 90-degree marker. So that means this one and this one have to add up to 90, right? Which is complementary, so we know that that's true. Good. That was a tough one. Good. Okay.